Hey everyone, my name is Yograj Sikka. I am student of Center for Global Education at Chitkara University in collaboration with Deakin University, Australia. Today I am demonstrating my task 4.3D, which is multiple inputs with timer interrupts for Arduino Nano 33 IRT. In this, we had to build multiple external interrupts which I had made earlier in the task 4.2C. In this, we had to include timer interrupts with a timer that fires at a chosen interval to perform periodic functions. In this, we need the hardware's Arduino Nano 33 IoT, one push button, two or more sensors. We had used air temperature sensor and motion sensor, three LEDs resistors for every LED. After that, we had used Arduino IDE to run the code. In this, we had to use SIMD21 library which we had installed on the Arduino IDE. Here you can see we had to firstly install the library by going to the sketch, include library. Then after that, going to manage library, we had to go for the semid timer interrupt, where we can find out the library. So we had to install point 0.7 extension library, so because that is compatible with our sensors. After that, we had to make sure that everything is working perfectly, and after that we had to implement the task and define the pin. So now let's discuss the code. So here is the code, you can see here. In this, we had to demonstrate we are demonstrating our task for the hardware timer interrupts. In this, it reads DHT22 temperature and humidity sensors periodically. Use volatile flags to safely communicate between ISRs and the main loop. Now let's discuss between what are ISRs and the main loop. ISRs must be shorts. They are only set for the flag and return immediately, not like the main loop goes continuously. After that, we had used volatile function to prevent compiler optimization that could change made inside the ISRs. After that, we had used SIMD library include we had included SIM timer interrupts library, which is useful in this task. After that, we had included the DHT library, which is used for the working of temperature sensor. After that, we had defined the pin, button pin on the pin number 2, peer pin on the pin number 3, DHT pin on the pin number 4, LED 1 on the pin number 8, LED 2 on the pin number 9, and LED 3 on the pin number 10. After that, we had defined the sensor type as the DHT22, and after that to create DHT sensor object. In this, we had made the timer setup. Choose a hardware timer TC3 for the periodic interrupts. After that, we had configure as we can request as an interval in microseconds. After that, we had used volatile flags. These flags are used for the ISRs and read in the main loop. Marking the volatile prevents the compiler from applying optimization that assume the value cannot change outside the current context. In this, you can see we had used volatile function to with the bool. So when the value is false, the button requests toggling LED 1. After that, when the LED 2 toggle flag is equals to false, peer motion interrupt flag request toggling LED 2, and after that timer flag is equals to false, timer interrupt flag request periodically work LED 3 plus DST sensor. After that, we had defined the LED states as the low in the initially, which means they are off. After that, unassigned long button to last record button press in milliseconds, which are 0 for everything. After that, we had used ISRs. We had defined a loop. We had made a loop which is void loop. In this, we had called the button pin detects a falling edge button pressed, keep the function tiny, and just the flag. After that, we had again used void loop. After that, we had again used void loop. These are for the every LEDs, which we had used for LED 1 toggle flag, LED 2 toggle flag, and for a timer flag. After that, we had made the main function initialization serial for debugging and demo narration. After that, we had defined the pin mode of every pin, like LEDs as the output and LED 1 pin as the LED state. After that, we had defined the pin mode of the button as the input, and pin mode for the pin as the input. After that we had given delay of 2000 milliseconds, which is equals to 2 second. After that we had given certain conditions for by giving the if by using the if loop. After that in the end we had used void loop. After that same we had used the if loops for the certain conditions. After that we had digitally write everything which we had given, same for DST sensor and same for the motion sensor. So now let's compile the code. So as you can see, the code has been uploading. You can see the code has been uploaded successfully. So now let's open the serial monitor. You can see serial monitor is giving us the certain conditions and the certain values which were be detected here. So now I will show you some hardware, how it is working and how it is properly showing everything. I will show you. So you can see here, this is my motion sensor. So whenever I will heat detect an motion, the LED will glow up, you can see here. And whenever it again shows, so you can see the LED has been switched off. I can handle the LED with the button also. So you can see we are handling the LED with button. So here the LED3 is glowing continuously, which is due to the temperature of this sensor. You can see here, these are my sensor. This is my motion sensor. Whenever it detects any motion, the light will turn on, like you can see here. Whenever it detects again, that light will turn off. Same with the DST sensor, it will delay, it will switch off for just microseconds, which will not be visible by the naked eyes. So this is my hardware. Now let's discuss the hardware. So here is the hardware of my project. So you can see D10 pin is connected to the LED1, which is further connected with resistor, and D9 to the LED2, D8 to the LED3. Here you can see D2 is connected to the right side of the button, and another side is connected to ground wire, which is further connected to the ground here in the Arduino Nano. And you can see 5 volt is connected here, and then further this first pin of the motion sensor is connected to the 5 volt. After that you can see D3 is connected in the middle and ground on the third part, and same with the same you can see here on the temperature sensor. Thank you, have a nice day.